Hello guys, welcome back to my channel. My name is Hassan Khurram, and in this channel I will teach you programming skills in Python, MATLAB and R programming. I also teach Tableau, a data visualization tool. So for today's tutorial I'm going to teach you a brief of bit of fundamentals in MATLAB programming. I'm going to teach you how you can actually generate contour plots in MATLAB. So the reason we are emphasizing on contour plots that because the contour plots are used to represent three-dimension data in two dimension using the contour lines, so which is widely used in engineering applications. So if you are an engineering student, that video is for you. Okay, so for contour plot we have like three set of values like x data, y data and the z data. Okay, where x and y are independent variables, y they actually represent the space and z actually represents the value that is dependent on the x and y. Okay, and so in that case z will be actually a contour value. Okay, so let's say take an example. We have a z which is a function of x and y. Okay, just in case we have like z is equal to sin x cos y. Obviously this function could be of in any form and any arithmetic equation as well. Okay. Now let's move on towards our practical programming section. So first of all, I have actually told you we have to generate the data in order to generate contour plot. So the first thing I'm doing, I'm using x and y as a variable declared in MATLAB, and I'm using function linspace. What actually linspace does, it actually creates a set of values between two intervals. Here we are passing three input arguments, -3, 3. So it will generate a set of values between the interval of -3 to 3, and how many values that you're going to generate is 100 values, and we are going to do the same thing for y. Now that being done, what we are next doing in this code is we are using function meshgrid, and we are passing two input argument x comma y. So basically meshgrid is something like it creates a space in 2D way. Okay, like it will give you a set of pair values for like every possible combination that we could have within the space of x and y. Okay, so it's kind of like actually create a space. Okay, or where for example we have like 1 2 1 comma 3 3 comma 4, and that's what on. So we have created our meshgrid. The next thing we are actually want to do is to calculate the z function. Remember, x and y are independent and z is something that is dependent on x and y. So we have like x and y values. Based on those x and y values, we will calculate the z function, which is actually a Gaussian like surface function. So it's kind of a bit of mathematics like there. You can go and search that on internet. So I mean, it's up to you. So let's move on and actually generate the plot once we have generated all the data set. So we are calling the function contour in MATLAB. We are passing three multiple input arguments. The first one is x and y, and the last one is z. So basically we are passing the data set x, y, z. Then we are defining 20. Basically 20 is kind of an interval that you must have within each line, and we have line width is equal to 1.5. So here an additional input argument that has been defined in the form of key value pair. So key is used to define what kind of function we want to input. In this case we are specifying line width. So contours by definition have lines to define the contour, so we want actually specifying that lines must have a width of 1.5. Once that done, we are using xy label that to label the x and y axis. Then we are setting the title of the plot, and when we are also setting the color bar, so we will also have a color bar along with our plot. And we are setting the type of color map to be where this it is a specific form of color combination that we have. And finally we are setting grid on, so we can actually visualize the grid line as well. So let me just run this code for you. Okay, so this is how a contour plot would look like. Obviously it's a Gaussian like surface function, so you have something a plot something like that, and it's quite aesthetically appealing to look at, you know. where the color map actually identifies the value of Z. Okay, so I think this color map is not defined in MATLAB environment. We might set it to jet. I think that would, yeah, so just is something available in MATLAB. Okay, where this is available in Python, so that's why I created an error. Okay, now there's another way that we can actually generate control plots, which are called filled control plots, and in order to generate those plots we are using function contourf. Okay, and we will pass the same number of input arguments, x, y, z. 20 defines the space between those things, and line space is equal to none. Okay, because we don't want to visualize the lines in this plot. So these are some additional input arguments that you can actually give to contourf. Then after that we have like x label, y label, title and color bar, which have been already defined. So this is how plots would look like. Okay, where you can see that the center value has the highest value of z, and as we move away from the center we have quite less values. So I know you might be wondering and you might be excited, like let's move on and actually generate a 3D contour plots, and that is exactly what I'm going to show you right now. So a 3D control plot is more of a like a mesh representation. Okay, so in order to generate that, first of all we initialize a figure, and after that we are using function mesh. So here we calling the function mesh, and we are passing 3 input argument x, y, z. Once we do that, we are going to label x, y, z axis. Once we done that, we are going to title the plot. We are setting the color map, and we are also setting the color bar, and we are setting grid is equal to on. So let me just change it to jet, so might be able to run it. Okay, I have to change that as well. So guys, this is the 3D control plot of a Gaussian surface, and it is quite interesting to look at. I know all those engineering persons who are kind of into mathematics as well, applied mathematics or theoretical mathematics. So with the help of contour plot, you are actually able to visualize your surface equations and so on. So I hope this tutorial have been helpful for you. If you have any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. Till then, peace out, have fun, yeah, for sure. And by the way, I also give programming sections 1-to-1 live with live training. So if you are kind of looking into that option as well, you just can contact me through my contact details on my website or even on my YouTube channel description. Thank you.